And then there's my feedback there that the tokens are issued. And just to give it a quick refresh again. So I should be seeing an increase again here of my Ubuntu tokens. And then there we go. So yeah, that's that. So that's essentially that's how the app works itself. It's a quick overview. And then now just to give like a background of how the blockchain itself works, I'm just gonna go to my demonstration here. So currently, like the internet as we know it, it's in a phase, it's in a version that we call 2.0. So it's Web 2.0. So what you do is essentially just a quick a run through. So you just go on your desktop or your mobile device or any other device that you use, and then you access your browser, right? And then when you're accessing your browser like this, you come across, let's say maybe you search www.instagram, and then you're gonna get that front end. That's the what you see on your screen, and then that is usually written in HTML, CSS, and JavaScript. And then now what happens is you make what we call CRUD functionality. So CRUD functionality, CRUD, I think it really summarizes everything that we do on the internet, because it's creation of content, it's reading of content, it's updating of content, and deletion of content. So for example, when I'm going into my Instagram and then I'm posting a picture, that's me creating content. And then when I go through a friend's profile, and then I look at the pictures, that's me reading content. And then when maybe I post a picture and then I want to edit the caption, that's me updating the content. And then when I'm not happy with my post, I delete a picture. Well, that's me deleting. So it covers all four operations of the internet. So now when you're doing either of those operations, you're making a request. So when you're creating, you're making a request onto a database, and then this database lives in a server. It's a server here, so that's why sometimes you're getting a 4. I think it's a 404 is not found. So the 404 is telling you that the server didn't find whatever resource that you were looking for. But then sometimes you get a warning, or rather an error that says server is down. So this is where it comes from. You make a request from your server to your server rather, and then the server gives you data, which comes in a response, comes back to your user interface, and so on and so on. Really, this is you. It's CRUD functionality, that side, and then you get a response coming this side. So you post a picture, it goes in there, and then you request a picture. You request a picture, and then you get a response. You see the picture. Just a quick, yeah. I mean, I think we quite aware of how Web 2.0 works. This is just a before describing how Web 3 works as well. So now, Web 3 is. I was making that description above just to show that there's actually parallels between Web 2.0 and Web 3.0. In a sense that you're still using your regular devices, your desktop, your mobile phone, and then you access your browser, whichever search engine of your choice, Google, Internet Explorer. So yeah, you choose your search engine, and then you make a request, you dial in your URL, and then you're going to see the user interface. So still the same thing that you do in Web 2.0. And then the difference just comes after that user interface stage, because now instead of requesting your data from a server, you're actually requesting your data from the blockchain itself. So now the blockchain, this is where we store our smart contracts and the data on our application. instead of the server. And then I'm going to explain, I'm going to give like a quick illustration of how this looks like. Yeah, but instead of the server, we request from a blockchain. And then, excuse me. So the smart contracts here, smart contract really is another name for a program. It's a program that lives on the blockchain. And then we build that program with Solidity. It's really a program, as I'm saying. So Solidity is excuse me. So Solidity is a programming language that we use to build our smart contracts. And then Truffle is the framework, and then Web3.js is a very critical piece of package, I think, because it's the one that gives us access to the blockchain using Web 2.0 technologies. So we have Web3 here. So Web3 acts like our API in Web 2.0. See, so that's why I'm saying like these two versions of the internet have parallels with them. There's differences, but then there's also parallels as well. So yes, that's a quick overview of how the blockchain itself works. And then now I'm just gonna give a code walkthrough. I'm gonna try to keep it as short as possible. So I'm just gonna quickly go into my let me see, to my terminal. So this is okay. Quickly just before I go through the code walkthrough. So there's a technology that I didn't mention as well, and that's very critical. It's called Ganesh. So what Ganesh is it's a simulation. It's a simulation of the blockchain. So if you can see, so this address here, the second address, is the address that I was using for my MetaMask. So if we can check, so this is the address here. So what an address is, it's really, I can describe it as something similar to like your bank account. So if someone wants to send cryptocurrency to you or any other token, they're gonna use your address. So working with MetaMask or cryptocurrency wallet comes with two things. It comes with your public address and it comes with your private address as well. So your private address is what you use to log into your MetaMask and then make transactions. You know, otherwise, like if people, you know, if you're using your public address to access your MetaMask, obviously people would have access to your tokens. So this address here is the same one that I was using for my MetaMask, hence the deductions. So they all start off with 100 ETH. They all start off with 100 ETH. It's not real Ethereum. It's test Ethereum. But yeah. And then yes, so these are my accounts here. And then these are my blocks. So blocks is the blockchain itself. So when you're making a transaction, that transaction gets it gets mined, and then it gets confirmed. So like the data about that transaction gets stored on the blockchain. So I've been making a lot of transactions deploying onto this blockchain, hence you're seeing so many blocks. But just to give a proper walkthrough, let me just start over my Ganesh and then show the whole deploying onto the blockchain of your smart contracts, and then show who gets charged when like the smart contracts are getting deployed themselves. So I'm just gonna close my Ganesh there, and then open it again. give it a few minutes, few seconds rather. There we go. So as it says here, one-click blockchain on your local machine. I'm just going to give it a quick start. I think it's a very interesting tool because like it helps you visualize what happens on the blockchain. But I mean, of course, there's other resources that you can use for this. I know there's Etherscan. So Etherscan is like it's like a website onto which like you can view all the transactions that are happening on the blockchain, either like a test blockchain or like an actual blockchain. And I'm going to show that as well. So see, starting off, we have 100 ETH for each account. And then let me just do the whole compilation of my contracts. So I'm just going to go back to my terminal again, do a quick shuffle compile. So I'm just going to be compiling my smart contracts. Compiling just to check that there are no errors, because that's another thing with the blockchain. It's immutable. Anything that you put on there is not going to come back down again. So you want to check that there are no errors before you deploy your smart contracts. And then feedback is telling me that everything looks good. So I'm just going to migrate my contracts now. And I'm going to do a reset. Doing a reset, I actually don't need to do this reset, because so what the reset does is, let's say I had already deployed smart contracts onto this blockchain. A reset is saying replace those smart contracts and then add new ones. But then since this is a new blockchain, I don't have to do the reset. Just going to migrate them there, and then I just want us to pay attention to what's going to happen to the balance of the first address here. Just going to compile quickly. There we go. Okay, so we deployed and there's no errors. So if you can just analyze this a bit quickly. So it's giving us a summary. We have total deployments, that's 4. So what happens is we're having 4 deployments, yet like we're deploying 3 smart contracts actually. But then I'm going to explain how that comes about. And then the cost is 0.052 Ethereums. So it shows that, in order to deploy contracts onto our blockchain, or to make any other transaction, you need to make a payment, which is the gas fee that I touched on earlier. And then I'm going to explain why it's saying 4 here while we're having only 3 contracts. So if we can just look here, the deploy contracts, it's the Pro-T token, the Ubuntu token, and the token farm itself. But then we are having a 4 here. So if you can just look at the first account here, so you see the balance went down. So this is because when you're deploying your smart contracts, this Ganache takes the first account to be the owner of the smart contracts themselves. That's basically what happens. This here is deemed as the owner of the smart contracts, which is the person that's deploying the smart contracts. And then in order to, so if you can just look at the blocks here. Let me see. Look at the blocks here. It's trying to show something. Let me see the transaction. So it's different. It tells you different things. It tells you different information about the block itself. You see the amount of gas that is used, when it was mined, So the mining is like the confirmation that, you know what, we are putting this information into the blockchain, and then the hashing, excuse me, and the hashing of the block, and then from address. So if you can just look at this address here, it should correspond with one of the addresses that we have here. 0, it's 79 AB, 79 AB. So it's corresponding with the first address. That's because the first address is the one that's responsible for the deploying of the smart contracts. And then the 4 that we have here is the, because what happens is when you deploy your smart contracts, there's I don't want to get to this point so soon, but let me just do this quickly.